Hello all, once again welcome to the LJ Institute of Engineering and Technology. Let's start with the subject Mathematics 2, same chapter, first order ODE, and today's topic is Bernoulli's differential equation, which is followed by linear differential equations lecture. That means we can say that reducible to linear differential equation. So in this method, first we will reduce that Bernoulli into linear, and then we will use same method as we have studied in previous lecture. Okay, so which equation is called Bernoulli? So the differential equation of the form dy by dx plus p of x y is equal to q of x into y raised to n. This term is only added in linear. So we have y and y raised to n is extra, okay, in this Bernoulli. Okay, here p of x and q of x both are function of x or constant, and this n is any number other than 0 and 1. If n is 0 and y raised to 0 becomes 1, so this becomes linear, and if it is n is equal to 1, so we have to merge this with this term, and it will be your variable separable. Okay, so n is other than 0 and 1, any number. So this is called Bernoulli differential equation, okay, of first order in y, in this y. How we can solve this? So for that, first we will divide this equation 1 by this y raised to n, extra power of y. 1 power of y is as it is, but we will just divide with extra power of y. Equation number 1. So we have 1 upon y raised to n, that means y raised to minus n. Here divided by y raised to n, and here y raised to n. So we have y raised to minus n and dy by dx plus p of x, and this become y raised to 1 minus n is equal to q of x. Now we will suppose this compulsory coefficient of p of x. We will suppose this only, and by supposing this we will get this term. So we have to suppose the term whose differentiation gives us this first term. That is our concept. Okay, so we'll suppose y raised to 1 by n is equal to v. By differentiating this term 1 minus n to y raised to minus n, because minus 1 1 cancel, differentiation of y is dy by dx and is equal to dv by dx. So y raised to minus n dy by dx become 1 upon 1 minus n. We'll take this on the right hand side. So by putting this value and this value in equation number 2, this is our equation number 2. Okay, so we have this first term become this, so this one, and second term will replace this with v. So we have this. Now to make it linear, we have to remove this coefficient, so multiply with 1 minus n. We have this term, and now this is our linear differential equation with this is our entire p, this is our q, linear differential equation in v. Okay, dv by dx, p into v is equal to q. Okay, so same way we will use this method in example. So we have y dash plus y is equal to minus x by y. So y dash is, we know that what is y dash, so dy by dx, and if we take this y numerator, so y raised to minus 1, so as I told, dy by dx plus p of x into y is equal to q of x into y raised to n, awkward power. Awkward, that means other than 1 power. So y raised to minus 1 is other than 1. Okay, so we will divide by this equation number 1 by y raised to minus 1. Okay, so same, divide equation 1 by y raised to minus 1. So 1 upon y raised to minus 1 becomes y, this y square, and this is simple. Now as I told, we'll suppose this coefficient of this p of x, here p of x is 1, so we'll suppose y square, such that by differentiating this y square we'll get this term. See how, let y square is equal to v, so differentiation is 2y dy by dx is equal to dv by dx, so dy by dx is equal to 1 by 2 dv by dx. We'll put this value and this value in equation number 2. So we have equation number 2 is this, we'll put this by 1 by 2 dv by dx, this is our v and this is our minus x as it is. So now we'll remove this to make linear. So we have dv by dx is equal to 2v is equal to minus 2x. Now we'll compare this with our this equation dv by dx plus pv is equal to q. So p and q must be equation of x or maybe constant. So we have p is equal to 2 and q is equal to minus 2x. Okay, so p is equal to 2 and q is equal to minus 2x. So what is if? So if is equal to e raised to integration p dx. So p is 2, so we have to integrate this 2 with respect to x. So we have e raised to 2x, which is our if. Now we will multiply this if with equation, sorry, by using this if, we have the solution. And what is the solution? The solution is given by v into if. Why v? Because we have this variable v, not y. So v into if is equal to integration q into if dx plus c. What is if? E raised to 2x. So e raised to 2x, e raised to 2x. What is q? So q is minus 2x. Okay. Now we'll use Bernoulli integration formula, same as we already use in Fourier formula, Fourier series. So u as it is, integration of this minus differentiation of this, integration of this, again differentiation of this is 0, so no need to go further. And by simplifying this, we have cancel out this 2, cancel this 2, minus minus plus, and by simplifying this we have this. Now we can replace the value of v, and we know that what is the value of v? We just suppose which was y squared, and now we can left this answer also, or we can divide this entire equation with by e raised to 2x. So remove from e raised to 2x, e raised to 2x, e raised to 2x, and here c upon e raised to 2x, that means c into e raised to minus 2x. This is our general solution. Simple. Similar way, we have one more example. Solve dy by dx minus 10y upon 1 plus x is equal to 1 plus x e raised to x sec y. Now here you can observe that here not simple y is given. Okay, that's why I have just taken this example. This is quite different from previous example. So here we will divide by this because we have dy by dx form. So this x is our q and this might be our p. Okay, so we divide this equation by sec x. So divide equation both side by sec x. So 1 by sec x, that means cos x, sorry, cos y. 1 by sec y, that means cos y. Now we know that tan y, that means sin upon cos, cos cancel, so we have sin y. Now suppose the term of y, by differentiating that we'll get this term. So we'll suppose sin y. So sin y is equal to v. So differentiation of sin y is cos y, and differentiation of y is dy by dx is equal to differentiation of v is dv by dx. So we will put this value and this value in equation number 2. So we have equation number 2. This becomes this dv by dx instead of this dv by dx. This is our v and this one. So we can equate this term, this equation with dv by dx plus pv is equal to q. So we have q is equal to this and p is equal to minus of 1 plus x. Okay, which is linear difference equation p. So we have p and q. Now by using this p, we have to find if. If is equal to e raised to integration p dx. So we'll put this minus outside, and we know that integration of 1 upon 1 plus x is log of 1 plus x. So we'll take minus on the power. So e raised to log of something is something as it is. So we have if is equal to 1 upon 1 plus x, or we can say that 1 plus x is to minus 1. Now what is the general solution? So general solution is given by v into if is equal to integration q into if dx plus c. So we put if here and value of q. So we have this if, value of q, this is our if. So this both cancel out. So we have integration of e raised to x, and we can write this as 1 upon 1 plus x. Integration of e raised to x is e raised to x, and we can replace this v. What was the v? V is our sin y. So we have sin y 1 plus x upon 1 plus x is equal to e raised to x plus c, which is our final answer. Okay. So in this method, you have seen that first you have to divide the entire equation with awkward power of y or awkward something function, so such that you can find the v, and by differentiating that v, you will find the first term. Okay, and then by putting in that equation, you will get the linear differential equation in V, and then you can solve the example. Similar way, we have this much. These are the example that you have to solve by yourself, and each and every example will help you in exam, and many of example already asked in GTO examination, so please try to solve this example. Okay, this will help you in might be GTO or in mid semester examination, okay, online or offline. So please try to solve each and every example. Here we finished our entire 8 methods: variable separable, reduced variable separable, homogeneous, non-homogeneous. Non-homogeneous has 6 methods. Exact, no, sorry, non-homogeneous has only one method. Exact, non-exact. Non-exact has a 6 method: linear and Bernoulli. And these 8 methods are for the first order, first degree differential equation. That means each and every differential equation is of order 1 and with degree 1. Now we have one last lecture in which we have differential equation of order 1 but degree is higher than 1. That means we have degree, that means we have term dy by dx is there, but power of this is more than 1, that means 2 or 3 or 4. That means this kind of equation are called first order is 1 but higher degree. Okay, so we have next lecture is of first order and higher degree of this chapter, which is last lecture of this chapter. Okay, so thank you for today's lecture, and please try to solve each and every example of the 8 methods so you will understand the next and last lecture of this chapter better. This will help in examination. So thank you very much. See you soon with next lecture.